Now you just took your own observations of the moon, and here are some other images of our moon. And now we're going to look at, why does the moon look the way it does? On some occasions we see an entire disk of illumination. On other occasions we see a thin arc of illumination, and otherwise shadow. So what determines what phase we see the moon in? And to do that, in the second part of our lab here, I'm going to use this tool that is available online. It shows the moon from two views. One is the bird's eye view here on this left diagram, taking up most of the page. And then we have the view here as viewed from Earth. So this is the moon from the Earth view, as if you're this person standing here looking up. What would you see if you looked at the moon? And then this whole left diagram is as if we were imaginarily out in space and could see the Earth and the moon and the sun. So that's a big clue that it's those three celestial bodies that lead to the phases of the moon that we observe on Earth. So three celestial bodies at play here. And of course, this diagram is not to scale whatsoever. So one thing about this tool is that you can click and drag the moon around the Earth in its orbit. And of course, it's not a perfectly circular orbit, but to eye it approximately is. And as the moon goes around the Earth in its orbit around Earth, even while Earth is spinning on its axis, you can see the Earth spinning on its axis there. And meanwhile, the Earth is going around the sun in its annual orbit. So we can see this bird's eye view shows illumination and shadow side. And this view on the right shows illumination and then a line between shadow and illumination, and then the shadow side. So we're going to do some more drawings of the phases of the moon from these two views. We're going to take both observations. In other words, observation from the bird's eye view, starting at this position, and an observation from the Earth's view over on the right. So let me show you the places in our lab that it's talking about. So we have this first diagram here, which is the view from space. And then the second diagram below it is just a series of lunar disks, and you can draw the phase in as viewed from Earth. So for each of these 8 positions, 1 through 8, each of these 8 positions of the moon going around the Earth, we're going to make an observation, a bird's eye, and at the same time, an observation as viewed from Earth. So let's take that first example. Position 1 is where it is located right now. And so, for example, if you were drawing the view from space, the line between illumination and shadow is this line right here, and it's perpendicular to the line between the moon and the sun. And that's one way of looking at the fact that the sun is illuminating the side of the moon that it faces. So you can draw exactly what you see here, render it as accurately as possible, shade in the shadow side, and in the disk, number 1, as viewed from Earth, they'll look for the line between light and dark. Here it's all shadow, so you would shade in where you see shadow in this phase of the moon. And notice the name of the phase is up here at the top, the new moon. And you'll do this for each position. Let's do another example with position 2, but your exercise is to go to 3, 4, 5, 6, all the way around to represent the types of phases, the 8 types of phases that we observe and name about the moon. Okay, so let's try observation number 2, viewed from Earth, and number 2, viewed from space. So number 2 is about halfway between the origin here and a quarter of the way around. So look at your bird's eye view, this diagram on the left, identify the line between light and shadow, draw that line, and shade in the side. Is it left or right? Shade in the side that is shadow. And that's your observation for this. So you draw it directly in there. Then go to the observation of the moon from Earth. So this is the Earth view of the moon. So where does that come from? So if you're standing here somewhere on Earth and you're looking up at the moon, you would see this side of the moon. You'd see mostly shadow in this little sliver of illumination, and this straight line between light and dark projected onto a sphere then appears as a curve. So you want to draw your curve between illumination and shadow as best you can. Try to judge how close it is to the disk or the middle of the moon. Try to represent it as accurately as possible and shade in the shadow side. And you will do this for all 8 positions. So each position, you draw what you observe in the disk for the viewed from space, as well as the viewed from Earth. And after you're done with that, then we have some analysis. The first part of our analysis is to compare what we saw in the 2 sections, the first and the second. So with Stellarium, you made a bunch of observations, and the question first asked is, do any of these observations that you made with Stellarium match the Earth view? So here are the observations of the moon with the Earth view, or from the Earth. Do any of these match any of your sketches in this section? So examine the shapes that you drew, and for the ones that you do find to match, write the dates around the orbit of the moon where the shape you saw in Stellarium most closely matches. So in other words, so let's go to the orbit of the moon and put dates besides these observations or these positions of the moon going around Earth. So making up an example, if you saw on March 28th, your phase of your moon matched what you see for position 2, namely here, what you drew for the phase for position 2 as viewed from Earth, then you'd put that date here. So any of the phases that you identify in here match your Stellarium observations, put that date next to the corresponding Earth view number. So for example, for me, I did find that on March 28th, the moon looked like what I found for the moon here as viewed from Earth. And so I wrote the date next to this observation, this position of the moon. First, we're kind of making a schedule of the moon's positions and what it looks like from Earth in those different positions. So we have some follow-up questions here based on your observations. Roughly how long do you think it takes the moon to go around the Earth? How do you know? Is the moon ever in the sky at the same time as the sun? And if yes, for which phase would this be possible? So you might find playing around with this tool helpful. So if you're someone standing on Earth and you're looking at the moon, if they're both in the same field of view at the same time, then those are those occasions. Then the answer is yes, sometimes the moon is up. Are there ever occasions when the moon and the sun are not up at the same time? So think about where the moon would have to be for it not to be up with the sun. During what phase is the moon highest in the sky when it is noon on Earth? During what phase, during what moon phase is the moon highest in the sky when it is noontime on Earth? During what moon phase is the moon highest in the sky when it is midnight on Earth? So one way to think about these two questions is think about where you would have to be for it to be noon. You can read this equivalently as noontime. So where would you be on Earth at noon? Okay, so here's noon. Where would the moon have to be for it to be highest in the sky? So for example, if the moon was over here, you would be looking across the horizon to see it. But if you were looking at it up here, it would be higher in the sky. So highest in the sky meaning directly overhead. So let's say you are at this position. This is about 6 a.m. So if something were highest in the sky, it would be in this direction. So it's asking for noon, and for another occasion here, midnight. For this person here on Earth, it's midnight there. What phase would the moon be highest in the sky? Or in other words, directly overhead. And here you're asked to mark on your diagram which position of the moon, Earth-Sun system, would you have the conditions for a solar eclipse? And likewise, where would the moon have to be for a lunar eclipse? So choosing amongst these positions, 1 through 8, where would the moon be for a solar and lunar eclipse is what it's asking. And that's our lab.